Welcome to this first module of this tutorial series. If you are here, you are ready to work with ROS2. In this module, we don't study theory. We will run a real ROS2 system. You will see nodes communicating, you will see data flowing, and you will control a robot. Let's start. We will use TurtleSim. TurtleSim is a very simple robot simulator. It runs in 2 dimensions. The turtle represents a robot, the keyboard represents a sensor input, and the movement represents an actuator. ROS2 sits in the middle. This is very important. With ROS2, the sensor can be replaced, the robot can be replaced, and the logic can be replaced. This flexibility is the power of ROS2. With this example and this simulation, you will understand the basics of ROS2. First, we will verify that TurtleSim is installed. This command lists executables from the TurtleSim package. If TurtleSim is installed correctly, we will see multiple executables. This will confirm that the environment is ready. Now we start the simulation. This command runs ROS2 node. The node name is TurtleSim node. This node creates the window and controls the turtle. At this moment, we have one active ROS2 node. Now we will start a second ROS2 node in a second terminal. This node listens to my keyboard inputs. When I press a key, the node generates a velocity command. That command is published in a ROS2 topic. The simulation node is subscribed to that topic, it receives the message and moves the robot accordingly. This is the publish subscribe model in ROS2. This is how nodes communicate in real time. Now we will inspect the system with this command. This command lists active nodes. We see exactly 2 nodes, one for the simulator, one for the keyboard. This confirms the system structure. Now we will list topics. Topics are communication channels. The important one here is CMD_vel. This topic carries velocity commands for the keyboard node to the robot node. ROS2 also provides services. A service is a one-time request. This command asks the simulator to spawn a new turtle. The request is sent, the response is returned. This is not a continuous data, this is a single operation. Now we will observe data directly. This command prints messages from the topic. When I press a key, I see velocity values. This is real data, and this is what robots will consume. Let's review what we learned in this module. A node is where the logic runs. A topic carries data between nodes, and a service handles one-time requests. This structure is modular and scalable. You can replace nodes, topic, or services without breaking the system. The turtle itself is just an example. What matters is the architecture behind it. This was the simplest example to get started. In the next modules, we'll start from the basics and gradually build up. We will create our own workspace, we will write our own nodes, and we will control robot behavior directly with code. Step by step, we will move from beginner examples to professional ROS2 usage. By the end of this series, you will understand and master ROS2 as a professional tool.